Hi, this is Mr. Hood, and we're going to look at 3 different ways you can use to subtract negative numbers. Let's look at 11 minus 14. If we were to model this using counters, we would start with positive 11, but then trying to model the minus 14 part is going to be a little tricky, because what we're asking to do is to take away 14 positives, and there aren't 14 positives. Looking at negative 8 minus 5, there's the negative 8 part, but again, the minus 5 part says I want to take away 5 positives. And in looking at the third example, we start with a negative 4, but subtracting 7 negatives, well, we don't have 7 negatives. So, moving forward in your high school and college math careers, it's going to be easier to think of subtraction not necessarily as subtraction, but rather as adding the opposite. So if we look at something like 11 minus 14, if we wanted to convert that to an addition problem, we would simply add the opposite, or 11 minus a positive 14 would now become 11 plus a negative 14. And now modeling this is pretty easy. There's our positive 11, there's our negative 14, there's our opposites being canceled. So apparently 11 minus 14, or 11 plus a negative 14, must be negative 3. Let's take a look at the second one. We're going to change that subtraction problem to an adding the opposite. So negative 8 minus a positive 5 is now going to become negative 8 plus a negative 5. So there's our negative 8. There's our negative 5. So apparently negative 8 minus 5, or negative 8 plus a negative 5, is negative 13. And now to convert negative 4 minus a negative 7 to an addition problem, we're going to change it to negative 4 plus a positive 7. Again, we're adding the opposite. So there's our negative 4, there's our positive 7, there's our 0 pairs being canceled. So apparently negative 4 minus a negative 7, or negative 4 plus a positive 7, or negative 4 plus 7 is simply positive 3. Okay, let's work those same 3 problems again, but now we're going to do them on a number line. So, first problem. To model 11 minus 14, we're going to start at 0, and we're going to do whatever the first integer tells us to do. In this case, since it's positive 11, it's telling us to move forward 11 spaces. Now, since this is a subtraction problem, the second movement is going to be to the left. How far? We're going to move 14 to the left. So here we go. Where'd we end up? We ended up at negative 3. For example 2, again, we're going to start at 0. We're going to do whatever the first integer tells us to do. And then, since it's subtraction, we're going to move leftward again. How many spaces? We're going to move 5. So now we're going to go 5 more spaces to the left. Where'd we land? Negative 13. Last one. To model negative 4 minus a negative 7, we're going to start at 0. We're going to do what the first integer tells us to do. And then, since it's subtraction, that means we're going to move to the left. However, because the second number is negative, that's going to negate or reverse that previous instruction. So in fact, what we're really going to do is move right 7 spaces. So where'd we end up? We ended up at positive 3. Okay, now the rules. How do we do this without using a number line and without using counters? Let's take a look at example A. And we're going to change subtraction problems to addition problems using the phrase keep, change, change. So what does that mean? Letter A. We're going to keep the first value as it is. We're going to change the subtraction to addition. And then we're going to change the sign of the second value. So now, are the signs same or different? Well, they're different. So that means we're going to subtract the absolute values. So that means strip the signs from each number and find the difference. So 14 minus 11 is 3. So we know the number part of the answer is going to be 3. And then to find the sign of the answer, we're going to steal the sign that's living in front of the bigger absolute value. Well, now the bigger absolute value is a negative 14, so that means our answer is going to be negative as well. Let's look at B. We're going to keep the first integer as it is. We're going to change the subtraction to addition, and then we're going to change the sign of the second value. So, are the signs same or different? They're the same. So that means we're going to add the absolute values. So strip the signs and add. That gets us to 13. And now the sign of the answer is going to be the same as the sign that's living in front of the bigger absolute value. In this case, the bigger absolute value is -8, so our answer is going to be negative as well. For letter C, we're going to keep the first value as it is. We're going to change that subtraction to addition, and then we're going to change the sign of the second value. In other words, -4 minus a -7 is going to become -4 plus a +7. So now, are the signs same or different? They're different. And so that means we're going to subtract the absolute values. 7 minus 4 is 3. And now we're going to steal the sign that's living in front of the bigger absolute value. And now, since the bigger absolute value is positive, that means our answer is going to be positive as well.